proof by cases is a proof method we can use where we prove a statement by breaking it up into discrete cases and then proving each one of those. So an example of this is the statement prove that n squared is greater than or equal to 0 for all n. So we have three cases that we need to look at. The case where n is greater than 0, the case where n equals 0, and the case where n is less than 0. Okay, so case number 1, well, if we have n squared, we can just rewrite it as n times n. And we know that if we have a positive times a positive, then that results in a positive number, so it'll be greater than 0. Case 2, when n equals 0, we just have 0 squared, which is just 0 times 0 equals 0. And case 3, where we have two negative numbers, we'll rewrite n squared as n times n. And we know that a negative times a negative is positive, which is greater than 0. And that concludes the proof.
Okay, so when is proof by cases helpful? This method of proving stuff is very helpful when we can't prove a statement with just one assertion. It's also very helpful when we can't do an exhaustive proof, which looks at every single possibility, because that would take too long. An example of this would be if we're trying to prove that x over 100 is less than or equal to 1 for x greater than or equal to 0 and less than or equal to 100. If we tried to use the exhaustive proof, in this case, we would go through x from 0 to 100 and prove that for each case that x over 100 is less than or equal to 1. This would take too long because it would go through all 100 possibilities as opposed to a case proof where we would look at just one case. In that example, we could say that x is less than or equal to 100, which satisfies all possibilities since 100 is the limiting factor in the top. In this method, we would say, or we could divide x both sides by 100, so we have x over 100 less than or equal to 100 over 100. This simplifies to x over 100 less than or equal to 1. Thus, it fulfills the statement we have here, x over 100 less than or equal to 1, for every x less than or equal to 100, which is every element in our set domain. Thus, instead of using exhaustive proof, this proof by cases is much quicker.
So, an important concept to consider with proof by cases is something called without loss of generality. Without loss of generality is applicable when we need to prove one case and no additional argument is needed to prove another case, which lets us to dismiss duplicate cases without weakening our argument. For example, if we're just trying to prove the statement absolute value of A times B equals absolute value of A, absolute value of B. So, in this case, there are 9 cases to consider. There's A greater than 0, B is greater than 0, A is greater than 0, B equals 0, A is greater than 0, B is less than 0, A equals 0, B is greater than 0, A equals 0, B equals 0, A equals 0, B is less than 0, A is less than 0, B is greater than 0, A is less than 0, B equals 0, and A is less than 0, b is less than 0. So this is a lot of work to prove this for every single case. But a and b are just variables, so they're interchangeable. So once we prove this statement for a is greater than 0, b equals 0, there's no reason we have to then do a equals 0 and b is less than 0. Similarly, we don't need a is greater than 0 and b is less than 0, and also a is less than 0, b is greater than 0. And when a is equal to 0 and b is greater than 0, we don't need a is greater than 0 and b is equal to 0. So this gets rid of a lot of work for us. We just reduce our cases down from 9 to 6. It's going to save us a lot of time.
So one of the common mistakes that people make when using proof by cases is that not checking every cases. When we miss out some case, we can get a false conclusion. So one of the example here is that absolute value of x is greater than 0. Okay, we check the case where x is positive. When x is positive, the absolute value of a positive is it's a positive number. And we check the case where x is a negative number. So when we take the absolute of x, where x is a negative number, we get a positive number. And from here we conclude that the absolute value of x is greater than 0. But we miss out the case where x is equals to 0. When x is equals to 0, the absolute value of 0 is 0, and it's not greater than 0. So this statement is actually false. So it's important to check every possible cases when we use proof by cases.